Hello, my name is Ardi, and in this video I'm going to explain on how to do node voltage, or some books call it nodal analysis. So there are 5 steps that we need to do. The first one will be pick reference node, and the last one will be do the dirty math. But first of all, we need to know what formula are for each component. So basically there are 3 components that we need to know the formula of, which is a resistor, and then the second one is the current source, and the number 3 is a voltage source. So let's dive into it. So the first one will be a resistor. So if we have a resistor, let's draw a resistor here, and this node here, let's call it node A, and then this node here, let's call it node B, and the value of a resistor is R, and we assume the current is going from the node A to node B like this. So this current here, I, can be calculated using this formula, which is the voltage in node A minus the voltage in node B divided by the value of the resistor. So this formula is called Ohm's law, right? So we usually know the formula of Ohm's law is just V is equal to I multiplied by R, but this is more detailed formula. So we have Ohm's law here, and then the second component that we need to know, that will be a current source. So let's see if we have a current source like this with the value of, let's say, I, and then maybe the voltage here is A and the voltage here is B. The only thing that we know from this current source is the current here. So the current here will be the same as this value of I. So this will be I here. So this is the current source, and another source that we need to know is a voltage source. So if we have a voltage source, and let's say that this one is A and this one is B, so put the extra caution on the sign here. So the positive one will be the top one. So I mean, if we have the voltage value here, V, that V will be equal to VA minus VB. So this is the formula for voltage source. So we know that this, after we know these 3 components, we can solve almost any problem in circuit analysis. Okay, let's dive into an example, and let's do each step one by one. Okay, so the first step is pick a reference node. Usually it is the bottommost node, so I just pick that bottommost node here as our reference node. A reference node is usually called ground, so let's write that. And in this case, the voltage in a ground will be always 0. Okay, and then we need to label all the essential nodes. Essential nodes is usually a junction or an intersection. So here we have this one, this one. Yeah, we have only 2 essential nodes. Let's name this as node A and node B, right? And then let's assume the direction of the current. Okay, if we have current source, just follow the direction of the arrow. Okay, like that. Because this arrow is going to the right, I will assume this will be going to the right also. And then for a resistor, you can assume, yeah, it's up to you. So I want to assume this direction, maybe this direction, and this direction. Okay, after you assume the direction of the current, you cannot change the direction of the currents, so be consistent when you do your calculations. Okay, so now we have this. What do we know next? Okay, after the label the essential nodes and assume the direction of the currents, now let's plug in the formulas. And one of the formulas that we need to know is KCL, right? And KCL, what does KCL say? KCL said that the sum of the currents that goes in is equal to the sum of the currents that goes out, right? Okay, now we have these two essential nodes, node A and node B. So basically we do KCL in these two nodes. Okay, let's do that. The first one will be KCL at node A. Okay, we have this current is going out, this current is going out, and this current here is going on. So yeah, all the currents is going out, so I will just put 0 on the currents that going in, because we have no currents that going in. And then we have what? We have this current here that going out, which is 12.5 ampere. Remember, if we have current source, we just put the value of this current source here, so that will be 12.5 ampere. And then plus we have this current here that goes from point A, node A, to node B, right? And remember that if we have a resistor like that, we will have VA minus VB divided by the value of the resistor, which is 2 ohm. So I'll have 2 ohm, and then one more here, we have VA here, and we need to know this node here. But remember that if we have a voltage source which is 100 volt, the difference between this and this will be 100, like this, because this formula, right? So we know that VB in this case will be the ground, so it's 0. So the voltage here will be 100. So I'll have 100 here. So I will have plus VA minus, I think I ran out of space, let's move that. Minus 100, so VA minus 100 divided by the value of the resistor between them, so I will have 1. Okay, now what can we do is just simplify this equation. I do not like to work with fraction, so maybe I will multiply both sides by 2, so I will get rid of all the fraction, and let's do that. So I'll have 0, 12.5 multiplied by 2 is 25, and this will cancel the denominator, so I will have VA minus VB, and then I will have this plus 2VA minus 200. Okay, and now I will have 175 in the left hand side, and then I will have 3VA minus VB. So I think that's all that we can get from the node A. So let's save this as equation number 1. Okay, now we need to do another KCL but at node B. Okay, let's remember that the KCL formula that we want to do at node B. So the sum of the current that goes in is equal to the sum of the currents that goes out. So I want to do this in node B. Okay, let's inspect node B first. So I will have this current here going into node B, this current here also going into node B, and this current is going out from node B, and this current here is going out from node B. So we have two currents that goes in and two currents that goes out. Okay, let's take care of the currents that goes in first, which is the first is this one. So that one will be 12.5, right? We cannot do anything about that, so let's write that 12.5. And then this current is also going in, so I will need to add it. So remember, if we have resistor, the formula is like this: I is equal VA minus VB divided by the resistance between them, and that will be VA minus VB divided by the resistance between them. The resistance between them is just 2 ohm. And then, yeah, this is all the currents that goes in. Now let's move on to the currents that goes out. So I will have this current is going out, and this current will be VB, this node here, minus the voltage here, but this voltage here is 0, so I'll have VB minus 0 divided by the resistance between them, which is 4. And then the last currents that goes out will be this one, so I'll have VB, and then I need a voltage here, this voltage here, but the difference between this and this will be 50. So, and remember, we have to pay attention to the sign here. The positive one is here, so this has to be lower than this, and the amount of lower is just 50 volts. So the voltage here will be minus 50 volt. Yeah, so I will have VB minus 50. Okay, I think I need to shift this left a little bit. Yeah, okay. And then we will need to divide by the resistance between this node and this node, right? So I will have 8. Okay, let's simplify this one. What can we do from here? I think we can multiply all of this by 8, right? Yeah, by 8. Let's do that. If we do that, 12.5 multiplied by 8 is 100. So I'll have 100. Then plus 8 and 2 will cancel into 4, so I will need to multiply the numerator by 4. So I will have 4 VA minus 4 VB, and on the right hand side, VB minus 0 is just VB. VB over 4 multiplied by 8, that will be 2 VB. And then this one plus 8 and 8 will cancel each other, so I will have VB and minus will be plus, so I'll have 50 here. So now let's move around a bit and solve them. So I will have, on the left hand side I will have 50, and then on the right hand side I will have minus 4 VA. I think plus what, 5, 3 and 5, 7 VB. Okay, Now we have this as equation number 2. We cannot do anything else other than doing this one. So now we have this equation here. 3VA minus VB is 175, and then I will have 50 is equal to minus 4VA plus 7VB. Now what can we do here is we do the math. We have two equations with two variables. We should be fine. So let's write down this first equation. So I will have 3VA minus VB is equal to 175. 3VA minus, what is it, VB is equal to 175. This is from the equation 1, and just rewrite this in here. Minus 4VA plus 7VB, that will be 50. Okay, what can we do from here? I want to do, yeah, this can be solved using substitution and elimination, right? Okay, what can I do is maybe I want to multiply this by 4, and I want to multiply this by 3. Okay, so I will have 12 VA, and then minus 4 VB, and that will equal to 175 multiplied by 4. I think that it will be 700, right? Yeah, hopefully I did not make calculation mistake. And then this one, minus 12 VA, and then plus, I think this will be 21, right? 21 VB, and that will equal to 150. Okay, now we can just add them up because this 12 and minus 12 will cancel each other. So I will have this. So I will have minus 4 plus 21, which is 17. 17 VB is equal to 180. But that means that we have our VB is equal to what? 850 divided by 17, that will be 50. Okay, if we know VB, we can get VA. So what is VA? We just plug this VB into this, right? So I will have 3 VA minus VB, VB will be 50, is equal to 175. Or I will have 3 VA is equal to 225. So maybe I will have VA maybe is equal to 225 divided by 3, and I think that will be 75. And remember the unit of the voltage will be volt, and this also volt. Okay, if the question is asking about V0, and V0 is just the voltage between these nodes, so this plus and minus signs will be the voltage, the difference of voltage between this node and this node. So if we are asked about V0, so V0, that will be VB minus 0. VB minus this voltage here, which is 0. Okay, and VB is 50, and 50 minus 0 is just 0. So the final answer of this question is V0 is equal to 50 volt. So to recap, we have 5 steps to do nodal analysis. Okay, hopefully this will help you to understand the step-by-step of nodal analysis. Okay, thank you for watching and bye-bye.